Approximately 50 years ago, Professor Michael Gazzaniga wrote about three patients seeking relief from epilepsy. They'd undergone a surgery that severed their corpus callosum. The corpus callosum is the largest of the nerve fiber bundles which bridge together the left and right hemispheres of the brain. In this image, you can see an intact corpus callosum on the left and a missing corpus callosum in the middle and right images. Split brain patients behave quite normally after this major procedure. This is because each hemisphere works independently and no major functions are lost. Yet, the hemispheres are no longer able to communicate. As explained by Gazzaniga, when the corpus callosum is severed, visual information can no longer move between the two sides of the brain, and it is no longer possible for one hemisphere to know something that the other hemisphere has experienced. Additionally, it's been discovered that the two hemispheres control very different aspects of thoughts and action. Each hemisphere of the brain has its own specializations, giving it limitations, but also advantages. The left brain is dominant for language and speech. The right brain excels at visual motor tasks, such as tying your shoes. And while this explanation is simplified, and the pop psychology idea of left brain and right brain personalities is a myth, what's important for us to know here is that the left brain can freely process language and speak about its experience. It has also been discovered that the left visual field goes to the right hemisphere, and the right visual field goes to the language-dominant left hemisphere. So, in this example, the right hemisphere is seeing a snow scene, and the left hemisphere is seeing a bird foot. If an image was projected to the left hemisphere, the patient could easily describe it verbally. When an image was projected to the right hemisphere, the patients reported that they could not see anything. Here, the patient is reporting seeing the bird foot and is not aware that the right brain has seen the snow scene. Yet, when asked to point out an object similar to the one being projected, they were able to do so easily. This is because the right brain saw the image and could generate the nonverbal response of choosing a similar object with their hand. It just could not talk about what it saw. The right hemisphere, controlling the left hand, correctly picked the shovel for the snow scene. The right hand, controlled by the left hemisphere, correctly picked the chicken to go with the bird's foot. Now, here's where it gets even more interesting. The patient was asked why their left hand had pointed to the snow shovel when they'd only reported seeing a bird foot. But the left brain hadn't seen the snow scene. And since the left brain was doing the language processing, it was the left brain who answered the question. The left brain did not know the correct answer, yet it quickly generated a verbal explanation. The left brain said the shovel was chosen to clean out the chicken coop. The patient fully believed that he'd chosen the shovel to clean out the chicken coop, but the researchers knew it was because the right hemisphere, connected to the left hand, saw a snow scene. Even when different pairs of scenes are shown to patients, the same finding proved true. The findings even remained when touch, smell, and sound were used. These studies shed light on the potential seat of false memories in the brain. These false memories are sometimes called confabulations. Confabulation is defined as a memory error in which distorted, fabricated, or misinterpreted memories are produced. This is different from lying in that the person confabulating does not intend to deceive and is unaware that what they're saying is not true. In general, people who confabulate are very confident about their recollections. Confabulation is a problem with reality monitoring, that is, deciding whether a memory is based on an actual event or whether it is imagined. And it has been suggested that confabulation is associated with an impaired strategic retrieval process. This impairment can be due to brain damage to specific brain areas, such as the ventral medial frontal cortex, or damage to areas connecting the hemispheres, like the split brain patients we discussed. Confabulation is a known symptom of Alzheimer's disease, Wernicke-Korsakoff syndrome, Anton syndrome, and some other types of frontal lobe damage, resulting in problems with retrieval of long-term memory. Studies of patients with brain damage make it very easy to determine when a subject is confabulating. However, confabulations have also been found in healthy volunteers. Confabulations may be a way for the brain to protect our self-identities and our sense of agency. However, the existence of confabulation has important consequences for ethical issues, such as implicit biases and testimony given during legal proceedings. If a hiring manager, for instance, believes he has no biases, he may confabulate a reason why he only selects male applicants to interview. Or, if someone who's particularly suggestible, such as a child, an elderly person, or someone answering to another in a position of power, they may confabulate testimony to match what is being suggested to them. It is important to remember that confabulation is not done with the intent to mislead. However, its implications in real-life situations should be addressed. Additionally, reality exists, unpleasant as it may be. Reality exists whether you believe it or not. And when we avoid reality, intentional or not, we have less chance of being able to contend with it and to think up solutions to the problems of reality.